Good day. This is AI Mathematics Akinla you. Last class, I was able to talk at the length on the concept, velocity time graph, distance time graph, and displacement time graph. That I was unable to solve questions. But today, I want to solve one or two questions to buttress the concept given to you in last class. A lorry starts from rest and accelerates uniformly until it reaches a velocity of 50 meter per second after 10 seconds. It travels with this uniform velocity for 15 seconds and is brought to rest with uniform retardation. Calculate the retardation of the lorry. Calculate the acceleration of the lorry, the retardation, total distance covered, the average speed of the lorry. Let me read the question again. A lorry starts from rest and accelerates uniformly until it reaches a velocity of 50 meter per second after 10 seconds. It travels with uniform velocity for 15 seconds and is brought to rest 15 seconds with uniform retardation. Calculate A, the acceleration of the lorry, B, the retardation, C, the total distance covered, D, the average speed of the lorry. Now, the first thing is that you need velocity time graph A. You need velocity time graph A. So you draw the vertical line and you draw the horizontal line like this. This is velocity or speed, and this time, this time. And when a body starts from here, it means that it starts from the origin, beginning here. And what that means that initial velocity is zero. And it accelerates because that day we discussed that, talk about that when you have velocity against time, the slope is what? Acceleration, which means the acceleration goes like this, like this acceleration. A, because we are not giving in the question. But let's start from rest and accelerate until reach a velocity of, which means we are giving the final velocity here because when it start from rest, it move along this. That's a 50. This is a 50 meter per seconds. 50 meter per second because we attain this final velocity here. Now, after 10 seconds, after 10 seconds, it travel with uniform velocity for 15 seconds. You know, that day also I said you uniform or constant velocity is like this, which means velocity remains the same for now. It travels with uniform velocity for 15 seconds, which means this side is 15 seconds. And it's brought to rest 15 seconds with uniform retardation. Retardation, also known as what? Deceleration, which means it's like it's this 15 seconds. Then, are we giving the retardation? No. Are we giving the acceleration? No. But we are asked to find the acceleration, retardation, and everything there. Using this using this graph now, we want to find the acceleration of the journey. We want to find the acceleration of the journey. And acceleration is change in velocity over time. Acceleration is what? Change in velocity over time, which means A is V minus U over T. A is acceleration, V is final velocity, U is initial velocity and T is time. Because we are asked to find the acceleration of that first journey. You know, A now, the final velocity is 50 minus you know is 0 because it starts from rest, 0 over time for the acceleration. Don't add everything. This time alone, 10 seconds. That's be 50 over 10. That's what? 5 meter per second square. Please don't forget units in physics. We have calculated the first acceleration, which means this one now is 5 meter per second square. 5 meter per second square. 5 meter per second square, which means we have calculated the acceleration. Then we have to find the deceleration, which means this slope here is slope downward is what? Deceleration. That's what we know it better. Is deceleration. Deceleration. This is 15 seconds. 15 seconds. We have to find this place. Now, there's one thing with acceleration and deceleration. You know, when we accelerate, the final velocity must be greater than the initial velocity. But when an object decelerates, the initial velocity must be greater than the what? The final velocity. You know, as this motor starts here, it accelerates. It reaches its final velocity here. The motor now starts going with the same speed. Then the same speed is still here, which is 50 meters per second. Which means this thing now starts coming to rest. Even if you are be able to drive, you can drive. You can see that in dashboard in front of a car, we have what we call speedometer. When it's parked, you see that the arrow will be at 0. But when you kick, it will still be at 0. But when you now start driving, you watch it, you start moving from 0, 10, 20, like that, depending on how you can fire. So, but if you want to stop also, when you apply brake, that speed you have will start to move, and the arrow will start to move backward, going back to 0, which means for deceleration now, our just still use a v minus u over t. But here our v is 0 because until it reach 0, until it come to rest and it's brought to rest, which means the final velocity is, because the moment you stop, apply brake and you stop finally, then you have come back to 0, which means it will be 0, and the velocity will be what? 50 over 15. That is because what? Minus 50 over 15. So when you do it, you will get 3 point something. 50 divided by 15. That's 3.33 minus 3.3 meter per second square. This is acceleration. You can see that we got the negative because the body decelerates. That's answer. Then the total distance covered. Here, you can use, I want to know both methods. You can use two methods in this number C. The total distance covered. You can find each area of the shape here, halves together. Or you make use of trapezium rule. Let's use the two. total distance cover now. Total distance cover. Total distance cover. So that's why mathematics and physics they go pari passu. So you know here we have three shape here: triangle, rectangle, triangle. Area of triangle is half base times height. Rectangle, length times breadth. This also is half base times height. We have three shape. Let's label it A, B, C. A, B, C. Then let me write this one here: minus 3.3 meter per second square. So now we want to find the total distance cover. Total distance cover. You can see that area of capital letter A is half multiplied by base multiplied by the height. The base here is 10. That will be 1/2 times 10. The height is what? The velocity here. That is 50. That's 2 here, 1, 2 here, 5. That will be what? That times 5, 25. That's 250 meter, because the distance we are calculating. Then area of B, that is the area of B is length times breadth. Length times breadth, this will be breadth 15. Height will still remain 50. And when you multiply the two, we have 50 multiplied by 15. You have 750. That will be 750 meter. The last one, area of C, that's half times 15 times 50. That's this is 5. That's 15 multiplied by 25. That would be 375. 375 meter. You can see that we are going to find the area of this. We got 250. This one we got the area is 750 meter. This one is 270 meter. We now add everything together. That would be sum of A and B. That would be 250 plus 750 plus 375 plus 750 plus 250. That's 1,375 meter. That's the first method. That's first method. You find the individual area, then you add everything together. So now another one that is very fast, but it's good to know both methods, because some question will demand that you make use of this, while some question will demand to make use of the one I want to use now. You can see now that area of trapezium that will be equal to what? Half into bracket A plus B height. So now our A, two parallel sides. You know this side now, you have 10 plus 15 plus 15. That will give us what? 40. That's half into bracket 40 plus B. B will be this length A. You know, from A to A is what? 15. That will be plus 15. Our height is 50. So that's give us half 40 plus 15. That's both times 55 times 50. That's the 2 year 1, 2 year 25. That's the 55 multiplied by 25. So you can see that we got the same thing. That is a 1,375 meter. That's that. So we are able to find the total distance covered by using two methods. The last question is that's the average speed of the lorry. Average speed of the lorry. Average speed of the lorry. You had every average speed is average speed is equal to what? Total distance over total time. Now our total distance is 1,375. Total time is what? This plus this plus that will be 40. That's 5 by 40. So that's the average speed will be 34.375 meter per second, or 34.4 meter per second. So thanks for watching me. Like me, share me, and follow me.